Hello everyone and welcome to the blockchains course. Been looking at some of the security aspects and we'll look at a deeper dive into membership and access control in Hyperledger Fabric and how Hyperledger Fabric provides this. We looked at this very briefly in one of the earlier sections just so that you understand what the membership notions are, but we'll look at it as a full lecture now. Hyperledger Fabric requires identities and policies at every stage of processing. So there is, within an organization, you can have admins and members, and they have identities. Organizations can run peers, and the peers have identities. The ordering service also has identities, and organizations can participate and run orderer nodes. And this could be just showing multiple organizations. So there are policies involved when you are installing chain codes and the identities are verified. So only an admin can actually deploy or install a chain code on a particular peer. So the peer's admin has to be installing chain code. If anyone else tries to install a particular chain code on a peer, it will fail. Right? So that's at the step of installing chain codes. Then there is instantiating chain code. So this is done at the channel level. So once you have the process, the chain code process itself running, you will have to tell which all channels on which it needs to execute. So then the admin is going to invoke this instantiate chain code call. So it's going to try and instantiate the chain code for a particular channel. The channel already has information about who are all the peers who have joined this channel. So it will go and communicate to all the peers who are part of the channel. So in this case, it has these 5 arrows. It communicates to all the peers saying, hey, for this channel, there is this new chain code which all of you have to instantiate. So all the peers will go ahead and instantiate that, and the channel is now reconfigured to include that chain code also. So that chain code is also part of the channel. So all of these also involve, so every step of this, there is identity verification. So only a peer, only an admin can instantiate a chain code on a particular channel. And to do that, that admin has to be part of an organization that is part of the channel. And the orderer will be performing this check to make sure this, whoever is invoking this, is actually part of the channel. If you're not part of the channel, you shouldn't be able to instantiate chain code in the channel. And again, when the orderer communicates this message back to all the peers validate whether this message actually indeed came from the orderer. So that identity check is done also. So this is overall the membership and access control architecture. It's built as, again, a pluggable framework. You could have different crypto service providers. So we'll talk about towards the end of this lecture about the crypto service providers themselves. So these are ones that are implementing different crypto algorithms. The membership architecture itself. So the membership service provider is really an abstraction of membership or identity management on blockchain. So regardless of what kind of membership you have, you can bring your own certificate authority, you can use the Fabric certificate authority that Fabric ships with. So regardless of what implementation you're using for your certificates, the MSP provides a uniform abstraction from separating the implementation of the identity management of how that is done from the blockchain platform itself. So MSP provides that unifying interface. So that allows you to plug in any kind of identity management structure, any kind of certificate authority into Hyperledger Fabric. So this membership architecture is there for per blockchain instance. So which means that every peer, every orderer, they all have an MSP within them. And this MSP will provide the unification across the different kinds of certificate authorities different instances might use. So even within peers themselves, organization A's peer can have a different certificate authority from organization B's peers, and MSP provides that unifying interface. So this allows for determining members of an organization who are the privileged users of an organization. So remember, only the privileged users can perform certain things like installing chain code and reconfiguring a channel and so on, right? And then there is access control framework based on the identities that are provided. Like for instance, what I just mentioned about privileged users being able to perform certain functions, it's actually a form of access control. And Hyperledger Fabric also gives you a language to express various combinations of roles and organizations. So it comes by default, the default Fabric CA comes with 2 roles. It gives you admin and a member role. But you can also have sub-organizations, like what we call as organizational unit. So you can also have that defined. And you can provide access control mechanisms on some of those roles and organization unit. And together, all of this allows you to give the access control policy. So all of this membership and access control is present at the system level, which is used for creating new data partitions or channels. It's there at a channel level, where the management of channel membership is managed based on this MSP and the access control. And it's also there at a chain code level, based on like managing chain code availability, who's running these chain codes, managing the access to the data that the chain codes provide. So all of this, at each level, there is membership and access control. And MSPs are defined on a per channel level. So it enables secure interaction of entities who belong to different organizations. And each organization could have their own identity management standard, right? So they can all use their own identity management standard, but MSP provides a unifying way of how each of them can talk to each other. So going to some details about MSP itself. So it's defined as a generic interface. Anyone can implement that interface, and it provides an interface for credential validation to check whether somebody has, so the person who's performing this transaction is actually a valid user. It provides anonymous but traceable authentication, and it also does a signature generation and verification. In addition, it can also do credential issue, but that's optional. Like you can bring in your own CA, which has already issued a credential, and you can plug that in to an MSP. Some examples of how one might implement an MSP is you could have one certificate authority that has a special kind of a X509 certificate, and maybe it has some extensions to it and modifies it in certain ways. Or it could be because you're applying certain advanced cryptographic protocols, and you might perform anonymous user authentication. So we'll actually talk about an example of this called Identity Mixer. I think I briefly mentioned it in the previous lecture. We'll talk about Identity Mixer in more detail in the next lecture, where it provides anonymity, unlinkability. It's actually a special kind of a certificate authority that Fabric is providing. And you can also have issuance of multi-signature certificates. So all of these can be provided as pluggable components using a common MSP interface. And Fabric Core itself implements 2 things. It implements a verifier MSP, which this is used by each client, peer, or orderer to verify the signatures of messages coming from other participants. And this is unique for each channel. And there is a signer MSP that is run locally at each component, and each component will use that to store and sign based on their private credentials. So only the signer MSP will hold the private keys. The verifier MSP will only going to have the public keys used to verify whether signatures are authentic. Now the application MSP is going to again implement a signer MSP and a verifier MSP. So the signer MSP is going to be the client side or the user certificate, user's private key, right? And it might have special attributes as part of that it uses those attributes to sign when it's signing. And there are also verifier MSPs that are used by the chain codes to figure out whether the attributes provided by the user are actually authentic. So these are the different places where MSPs are used. So Fabric implements a standard PKI based MSP. This is implemented by default by Fabric, but you can have other implementations as well. It uses a standard X509 certificate as a notion of identity. And this is governed by standard PKI hierarchies. So this kind of certificates are used routinely in internet applications. And what they are governed by is the fact that there is a root CA who is trusted, and that CA will sign and say, okay, this certificate actually belongs to Praveen. And the CA could have multiple intermediate CAs just for hierarchical purposes. And it could also maintain a certificate revocation list. So periodically these certificates might get refreshed and new certificates might be issued. And the CA will maintain which certificates have been revoked in the past. And what Fabric supports is ECDSA, which is elliptic curve based digital signature authentication. And it also provides some limited support for RSA based keys, but predominantly it uses elliptic curve based digital signatures. And the validity is based on whether the root CA has actually signed it and whether it's verifiable, right? So you need to have the public key of the root CA to make sure that it's actually signed by that root CA. The standard implementation of MSP provides no anonymity. So if you look at the certificate, you'll know exactly who performed that transaction. So it does not give you any notion of anonymity at all. The identity mixer, which is the advanced notion, and it's a Fabric CA implementation itself, that provides anonymity and unlinkability. But the standard MSP implementation does not give you anonymity for your transactions. So signature generation verification is a standard public key crypto operation. So you're going to use your private key to sign, and people who have your public key can verify it was in fact you who provided that digital signature or performed that transaction. So like I mentioned, you can use a commercial CA off band, or you can use Fabric CA that comes shipped along with Fabric. And you can use that Fabric CA in your application. And IBM blockchain platform right now does not allow you to plug in your own CA, but you'll have to use the Fabric CA implementation. But I guess at some point in the future they will allow that capability as well. That's on the verifier MSP, and if you look at this part, this does not have any private information at all. It only has public information required to verify signatures that others have signed. The signer MSP is where the private key is held, and it includes apart from the verifier MSP portions, apart from the X509 certificate with public key, it also has the private key that you will use to sign. So that's what the function of the signer MSP is. And this signer MSP, as I said, is part of the clients, orders, peers, every component in the network. They will all use this to sign their transactions or sign their messages. And MSPs provide the core building blocks for you to then get to access policies. And like I mentioned, there are access policies at every stage of Fabric, whether it's channel creation, channel membership management, chain code management, chain code data access, everything is can be controlled through access policies. MSP allows you to do provides role-based. So you can, right now it implements two roles, member and admin. You can do identity-based based on a specific identity. Or you have the notion of an organizational unit, which you can think of it as a department within a larger organization or a sub-organization within a larger organization. So what do some examples look like? So for instance, aliceco.admin and charlieco.admin means that both of these have to have signed for you to accept this. These AliceCo, BobCo and CharlieCo are existing MSPs, existing organizations on the network. And this rule says that both Alice and Charlie have to have Alice's admin from Alice and a member from Charlie should have signed this transaction. The second one is aliceco.admin or charlieco.admin or bobco. So any one of these, if they sign, any one of these admins sign, then it's okay. The last one shows an example of an organizational unit. So the finance division of Charlie company, if someone from there signs this transaction, then it's accepted. So, I'm saying transaction, but it's for any kind of message exchange and so on. So that's the kind of access control language that Fabric provides. You can use any kind of these and/or rules. It also provides the N out of K rules, but I've not talked about it here or shown examples of that. Okay, so that was all about identities and access control. The next aspect of it is the crypto service provider. So these are the cryptographic algorithms or the operations that you would use based on the identities that you have. Right? So one of it that is implemented is the elliptic curve based digital signature. So that's one part of it. So apart from that, even this part of it, the crypto service provider can be a pluggable. It is actually a pluggable component. So you can come up with your own implementations of these crypto operations. And the neat thing about this is you can also use this to connect to hardware security modules. We'll talk about that in the next slide, where some of the signing is happening in hardware so that the key is not even exposed in software. So no one can hack in and steal your key. And it also provides international standards support, and it gives you the ability to provide even more fine-grained confidentiality features beyond what is implemented today in Fabric. So this is an example integration of hardware security modules with Hyperledger Fabric. So this is the usual Fabric components: orderer, endorser, client, and so on. So as I mentioned, there is a membership service provider along with this, and that membership service provider interfaces with a crypto service provider, a CSP. So there could be a CSP in software, or it could be a HSM based CSP, right? So now the HSM is a hardware security module which securely stores your secret information, and that secret information will not leave the hardware at all. So the signing would actually be performed in hardware. The secret never leaves that. So which means that even if someone hacks into your software, they will not be able to find out what your private key is. And there are open standards for this. There's something called PKCS, Publicly Crypto System. And it's basically an interface and a standard for interfacing with cryptographic tokens, such as a HSM, a hardware security module, or a smart card. So there are standards for this, and the standard implements an interface called CryptoKey, crypto token interface. So there are open interfaces and standards for how you would interface with HSM. You can actually use those to connect a membership service provider and a crypto service provider to a HSM module. Fabric also provides certain tools as a convenience feature for you to help you bootstrap a network. So one of those tools is CryptoGen. It's a tool to generate crypto material for your users in your organization, for your peers. You need to be able to generate certificates. So all that can be generated by CryptoGen. So you can just tell CryptoGen, I have 4 organizations, I have 3 peers, generate material for it. So it will go and generate the crypto material needed for those organizations. Another tool is CryptoTXGen. So this ConfigTXGen, which is configuration transaction generator. It's a network bootstrap code which is designed so that organizations can be included as part of the ordering service genesis block. So it's basically to tell the ordering service that these are the organizations that are going to be part of the network, and it generates the configuration transaction and the genesis block to create a channel. Right? So it has all the crypto material for orderers, peers, certificate authorities that are needed. It then goes and creates the genesis block, and it also has a configuration transaction that tells the orderer and the channel that these are the organizations that are participating, these are the peers who are part of the network. And in future, that configuration transaction, you can create other instances, you can modify that configuration through channel configuration transactions. So that is also possible as long as you are an admin of that channel. So that is an important access control that you'll have to satisfy. So those are some of the features in Hyperledger Fabric with respect to membership and access control. So some reading material on this. So the MSP itself it's a slightly sophisticated concept, I would say, about how to abstract different notions of identity and membership on Hyperledger Fabric. So you can read up the Fabric documentation on that. That gives you some examples as well. If you are not aware of what hardware security modules are, I would encourage you to look up the Wikipedia article on it. It gives you a good overview of that. And the PKCS standard is also a good read. Just look that up on Wikipedia, you'll understand what that is about. That concludes this lecture. In the next lecture, we'll actually dig deep into privacy aspects and how Hyperledger provides some of those features. Thank you. See you soon.